Welcome back to the GCSE Maths Pro YouTube channel. Today's video is going to be a summary of the whole topic of proportion. So we're going to be looking at small snippets of each of these 4 individual videos. If you want to go back and have a look at some more examples of questions or a more detailed explanation of each of these, I will list below all of the individual videos so you can click on the links from there. So before we jump into any questions, this is basically the most key part of the whole proportion topic. If anything, these are the 2 formulas you just need to memorize, okay? So this is our starting point. So we've got here, if you have a question that says, and obviously I've used y and x, but they could be any letters in the question, right? It could be any letters. Y is directly proportional to x. Therefore, the formula I need is this, y equals kx, or in other words, k times x. Now, k most of the time just represents what we call a constant. It's just a number. We're going to find out what that number is depending on each individual question. So just remember it is k times x for direct proportion. So direct proportion and inverse proportion, the questions can be laid out in different ways. We're going to start off by looking at this kind of table format, but really the steps are always the same thing, okay? So we've got here y is directly proportional to x. First of all, what does that even mean? Well, proportional just means there's a relationship between the 2 things. In this context, y and x, there's a relationship between y and x. Direct proportion, or being directly proportional, means, for example, if y increases, x would also increase. If y decreases, x will also decrease. So they're kind of going in the same direction, if that makes sense. This one, it just says complete the table. Okay, well, yeah, if you haven't seen this before, you're not going to know where to start. So our step 1, we're going to go by steps. Step 1 is always to figure out which formula do we need. So that previous page we just looked at, as I said, is our starting point. Because it says direct proportion, I'm going to use the direct proportion formula. And I'm going to write it, if let's say I know I've got x and y here again, but let's say if I had different letters, you just write the formula in the same order that they write the letters. So you see how y comes first in the sentence and then x. So in this case, I've got y equals k times x, y equals kx, as we saw in the previous page. That's my starting point. Okay, great, but yeah, well, where do we go from now? So what we have to do is, step 2 is always what we call find k, which is our constant, isn't it? The number. We need to find what number is this k. Well, you will always be given what I like to call a matching pair. In this case, the matching pair, as you can see, is, let's say, for example, they'll say when x is this, y is that. In this case, they've given it to us in the table. You see this column here. We know that when x is 9, y is 27. So that's our matching pair. What that means is we need to substitute in both of these into our formula. What we mean by substitute is replace, isn't it? So what I mean by that is y, instead of writing y, I'm going to write 27. So I've got 27 equals k times by x, but we know that x is 9 at the same time, isn't it? Okay, cool. Well, I'm going to rearrange that to write it as 27 is equal to 9k, isn't it? We always put the number in front of the letter. Now, to find k, do you see how now my equation, I only have k left? That's perfect, because when we're solving an equation, we can only have one letter, can't we? We've got k, that's it, perfect. This is just algebra. I just need to solve this equation, don't I? So normally with algebra, to solve it, I want to get like k equals. Well, currently I have 9k, not 1k, right? So how do I get from 9k to just 1k? I would have to divide by 9, wouldn't I? And because it's an equation, we have to do it on both sides. So I'm just going to bring it over here. Obviously, on the right, 9k divided by 9 is just k, and 27 divided by 9 is 3. Perfect. So now we know that k is 3. Now, before I jump on to the next step, I don't like to get ahead of myself. I kind of write this little therefore symbol. I'm going to rewrite my formula, but instead of k, I can write down the number 3, can't I? So my actual formula is y equals 3x. Perfect, so that is my proper formula. So you're going to do this for every question. Now that we have our actual formula, we can actually do step 3, which is what I like to call answer the question, right? actually do what the question is saying. In this case, it's saying complete the table. Okay, cool. Well, let's look at our column on the left here, the first column. We've been given y is 15. We need to find out what x is. So I know my formula is y equals 3x. So we're just doing more substitution, aren't we? So I'm going to put like part A here. And this one here is part B, isn't it? So part A, I know that y is 15, so I can replace the y with 15 equals 3x. Again, I'm just solving that equation, aren't I? I just want to find out what is x. So I have to divide by 3 on both sides to get 1x. So that's x, and 15 divided by 3 is 5. Perfect, so that is 5. And B, same again, except you see how now we've been given x. Okay, we've been given x as 13, we need to find out y. So when I use this formula, I don't know what y is, so I've still got y equals, and then 3 times by x, but x is 13, so that's what I'm going to substitute in. This one doesn't need any rearranging, does it? All I need to do is literally just do what is 3 times 13, which I know is 39. There's my answer. Okay, so every question you're going to follow these 3 steps. Number 1, what is my formula? Number 2, I need to find k using a matching pair that they have to give you. And number 3, answer the question, whether that's just one question or like this was kind of like 2 parts, wasn't it? Just depends. Our first 2 questions were quite straightforward. It was just y is directly proportional to x, wasn't it? Do you see here how it's slightly different? You have to be really careful, read the question properly, because it says y is directly proportional to x squared, okay, not just x. Sometimes this second letter might not just be the letter on its own, it might be squared, cubed, square root, could be anything, okay? When y is 90, x is 6, that's our matching pair again. Find the value of y when x is 2. We're still going to follow the same 3 steps, okay? Step 1, we said, was the formula, wasn't it? Y is directly proportional to x squared. So we know that the normal formula is y equals kx, but we don't have just x anymore, do we? We have x squared. So include that when you're writing down your formula. Okay, step 2 is find k. Now it's all the same. I'm going to substitute in my matching pair. So y is 90, and we've got k times x squared. Now in this case, it's therefore going to be 6 squared, not just 6. So to solve this, I'm going to do what is 6 squared? Well, that's obviously 36. I can write it as obviously 36k in that case. And then all I have to do to get k is divide across by 36, isn't it? So 90 divided by 36 is 2.5. You might prefer to keep it as a fraction, which is 5 over 2. Really doesn't matter, it's up to you. Okay, then I'm going to write my therefore. What is my actual formula? What is my actual relationship between y and x squared? Well, that's y equals 2.5 x squared, isn't it? Or as I said, you might write it as y equals 5 over 2. X squared, same thing, doesn't matter. Okay, now we can go on to step 3, which was to answer the question. We've got here, find the value of y when x is 2. So just really double check that you read the question properly as well here, because sometimes they swap between giving you y and then giving you x, and then having to find whichever one of the letters. This time we've been given x. So I've got y equals 2.5 times by 2 squared. Okay, well 2 squared is 4, isn't it? 2.5 times 4 is 10. There we go, y is 10. That one I don't have to rearrange because the y is already the subject of the equation, isn't it? It's already on its own. So I just had to work out 2.5 times 2 squared. There's your answer. So we've still got the same steps even though it's an x squared, okay? Just remember to add that in at the start. Okay, so hopefully by now you've got the idea. It's quite repetitive. The last 2 questions that we've got are now going to be worded questions. As you can see, it's not just y is directly proportional to x. We've got an actual scenario. However, you should be able to see that you can still break it down into those 3 steps in those 3 sentences. So the cost, which they're telling us to use the letter C for, of a hotel is directly proportional to the number of days, D, spent there. Okay, so we're using C and D this time. All of our previous examples were X and Y. However, as I said at the start, you could use any letters. It could be any letters in your questions, okay? So just be aware of that. It costs £250 to stay for 5 days. How much would it cost to spend 9 days in the hotel? Okay, we've still got the same exact 3 steps, haven't we? The first bit, which is the relationship. The second bit, which is our matching pair. And the third bit, which is the actual question. So step 1, we want our formula, don't we? As I said, if they use different letters, just write the formula in the same order as the letters appear. So for example here, C is first, isn't it? So I'm going to put C equals, still K, isn't it? Because it's always K for our constant. And then where it would normally be X is now just D. Okay, that's it. You just write it in the same order that you can see it in the sentence. Step 2, use our matching pair to work out the value of K. So in this case, the cost is 250. So I'm going to put 250 equals K times the number of days, which is 5. Again, we can swap that around to be 5K, can't we? And to solve to find K, we just need to divide by 5 on both sides. So 250 divided by 5 is just 50, isn't it? So in this particular question, K is 50. I'm going to do our little therefore, rewrite the formula, but with K as a number. So C equals 50D. What that's basically saying is the cost is equal to 50 times the number of days. So effectively what we're saying here is that it costs £50 a day, doesn't it? Okay, finally, step number 3, answer the actual question. How much would it cost to spend 9 days in the hotel? Well, that's 9 for D, isn't it? So C equals 50 times 9, which should give us 450. Okay, so the answer in this case, in the context, is £450. So you can see, even though it's a worded scenario context kind of question, I've still followed the exact same 3 steps. I just kind of have to decipher a little bit, figure out my starting point with my correct formula, but from there, it's the same thing, isn't it? Inverse proportion is where there's a relationship between y and x, but it's kind of going in opposite directions. For example, if y increases, x would decrease, and vice versa. If x increases, y would decrease. So this y equals k over x is the formula you need to memorize, as well as obviously the other one for direct proportion. This will be our step 1, our starting point for each question. So as we did with the direct proportion video, we're going to start off with a question that's laid out as a table. Now, if you've seen that video, you'll know that we're going to be working with 3 steps. Okay, so I'm going to go through it again. Basically, the 3 steps are, number 1, what is our formula? So the page we just literally looked at, as I said, is our starting point. We have here y is inversely proportional to x. So I know the formula is going to be y equals k over x. And remember, k is just a constant. That just means a number, which for each question will be different. So we'll find out what k is for this particular question. So we've got our formula, that's our starting point. Step 2 is, as we've just said, find k. Now we do that by using what I like to call a matching pair. They will have to give you a pair of values. So for example, when y is equal to this, x is equal to that. Now in this case, because we've got a table, you just have to look at the column where you're given both. So you can see here, when x is 10, y is 0.5. So that is our matching pair. Effectively, it's just algebra, isn't it? We're going to substitute in both of these values to our formula. So where it says y, I'm going to put 0.5. Or if you prefer, you can put a half. And then where it says x, I'm going to put 10. Now I've got an equation with just k, and obviously because I'm trying to find k, I just need to solve this equation, don't I? So all I need to do is rearrange by timesing across by 10, because that will leave me with k on its own, won't it? So I've got k on the right, and 0.5 times 10 is 5. So in this particular question, this particular relationship, k is 5. I'm going to do exactly the same things I did with the direct proportion. I'm going to write therefore, my formula for this particular question is y equals, instead of k, I'm going to write the actual number, which I now know is 5, over x. So that's our actual proportion relationship, y equals 5 over x. That's the formula we're now going to be using to answer the question. So step 3 is then answer the question. Now in this case, the question is to complete the table, isn't it? So we kind of have two parts to that number 3, don't we? We have part A, which is this first box, and part B, which is the second one. We're going to, let's say if we start with the first one. The first one tells us we know that y is 1. What is x? So using my formula here, part A, I can substitute in y equals 1. So 1 equals 5 over x. Now, just be really careful here, because a lot of people just think that we can just divide by 5 and get x. Okay, this is more so to do with knowing how to rearrange equations than anything. But it's a bit more complicated when x is in the denominator of the fraction, okay? Yeah, I can divide by 5. If I divide by 5, I'll get 1/5 and I'll get 1 over x. It's not like the x suddenly becomes the numerator, right? It's not like the fraction suddenly disappears. No, I've just taken away the 5 from there. So, to rearrange this type of equation, so when we're using the formula for inverse proportion, I actually kind of need to do 2 steps. I need to move the x. Sometimes people don't realize you can actually move the letter you're looking for. Like, obviously I'm solving to find x, but it doesn't mean I can't move the x. Currently, that's 5 divided by x, isn't it? So I can just times by x, that's fine. So let's say if I times across both sides by x, obviously 1 times x is just 1x, so just x, and then 5 divided by x times by x, well obviously that's just 5. Now luckily I haven't had to rearrange this any further, have I? Let me just write it over here because it might be cutting off. So I get x equals 5. Sometimes you might need to rearrange a bit further from there. In this case, we don't have to. Okay, so x is 5. So let me just undo that so I can write part B. We got there. X is 5. Okay, part B, let's see. Now this time we're given x, aren't we? We need to find y. So looking at my equation, I've got y equals 5 over, and then x is 25. Okay, this one I don't need to rearrange because y is already the subject, isn't it? It's technically already solved. However, I could simplify that fraction. 5 over 25 simplifies to 1/5, doesn't it? So I might just simplify that. And there we go. So if you have seen the first video on direct proportion, you can see it's exactly the same steps. The only difference is we've got a different formula to start with, isn't it? Otherwise, still write down the correct formula, find k, answer the question. Okay, very repetitive. So this next question is again very similar. The only difference is that we have a square root of x. Pause the video, give it a go if you feel happy with the method by now. So y is inversely proportional to the square root of x. When y is 30, x is 9. Find the value of x when y is 18. Okay, we're just going to copy exactly the same thing again and again, aren't we? Step 1, what is our formula? Okay, well it's inverse proportion, so I know it's y is k over x. However, it's not just x, is it? It's the square root of x. So I've got y equals k over the square root of x. Step 2, we want to use our matching pair to find k. So substitute in 30 equals k over the square root of 9. Okay, before I do anything, I'm going to literally just square root the 9. So that's 30 is equal to k over 3. And then I have to times across by 3, don't I, to get k. So let's bring that over here. So 30 times 3 is 90, and that equals k. Okay, therefore, my actual formula, my completed formula, is y equals 90 over the square root of x. Here we go. Alright, and the final step, step 3. We want to actually answer the question. So find the value of x when y is 18. So I'm going to substitute in 18 for y. So 18 equals 90 over the square root of x. In that case, again, I'm going to move the x across, but as it is, it's root x, isn't it? That's fine. I'm just going to times by the square root of x. So I get 18 square root x equals 90. I'm then going to divide by 18, so I'm kind of swapping the root x and the 18, aren't I, basically? So root x equals, and then that should be 5. And then to reverse the square root, I just need to square. The opposite, isn't it? Square. So x and then 5 squared is 25. So there's your answer. So just be really careful when you're rearranging the inverse proportion formula if you're given y, because we have to actually move the x or whatever the x is with. So if it's x squared or if it's going to be root x, we have to move that as well, don't we? Okay, our last two questions are actually relating to both inverse and direct proportion. Most of the time, the way that they can make this topic harder is just by doubling the amount of work. So as you can see here, we've actually got two relationships, two matching pairs, and then obviously a question at the end. So in this case, we're just going to do our same process twice. So the first two steps, we're going to do them twice for each of these relationships, and then we'll get back to the question in a minute. Step 1, let's have a look at the first sentence. Y is directly proportional to x. I'm going to do that over here on the left in the blue. That means I need my formula. Y is directly proportional to x, so I know that's y equals, if you remember from the first video, kx, isn't it? Okay, cool. Now, let's do step 1 of the other relationship. I'm going to do it in pink. Put it over here just so that we have enough space. X is inversely proportional to z, so it's inverse. So we've got x equals k over z. Okay, so that's step 1. Step 2, look at your matching pairs to find k. So for the first relationship, I've got when y is 12, x is 20. So I'm going to substitute in both of those. It's basically k times 20, isn't it? So I'm going to put 20k just to simplify it. Obviously, to find k, I just need to divide by 20, don't I? Across. Divide by 20. So 12 divided by 20 is going to be 3/5. Technically, that's also 0.6. It depends if you prefer fractions or decimals. Okay, and then we put therefore, what was my actual formula then? Y equals 3/5 x for the first one. Okay, now let's do step 2 for the second one. So using our matching pair, we want to find k. Obviously, the k is going to be different in each relationship. So when x is 7, z is 2. So I've got 7 equals k over 2. I'm going to times across by 2, which gives me 14 for k. And therefore, this equation is going to be x equals 14 over z. Okay, so basically done the first two steps, but twice, haven't we? Twice over. Now let's look at part 3, which is answer the question. What is the value of y when z is 6? Now this is probably where you think about it. First of all, there's only one question, not a question for each. But have a look, we've got y and we've got z. Well, there's y in this one and z in the second equation, isn't it? They're not in the same equation right now. So we need to link them, don't we? Step 3, they've given me z is 6. So really I have to start with the second equation, don't I? So I'll put step 3 in both colours. Step 3, we have to start by substituting in z is 6, which means using this second equation. So I've got x equals 14 over 6. What does that simplify to? 7 over 3. Okay. Then how do I use that to find y? Well, if you look at the other formula, y has also got x in it. So now I can take my x value and substitute it back into the first equation. So y equals 3/5 times by x, but we know x is 7 over 3, isn't it? Perfect. When you multiply those, you actually get 7 over 5, or 1.4 if you're using decimals. So I've kind of had to jump backwards, haven't I? Starting with the z, find out what x is, and then use the x, which is common in both of these equations, isn't it? They both have x in them. So I have to find out what x is and then put it into the other equation to find y. Okay, so it's really not too difficult. You're just doing everything almost twice, aren't you, basically? Your final answer for this one is y is 7 fifths. The type of question I'm talking about when I say worded inverse proportion, it's not the worded scenario ones we saw at the end of the last video. It's actually ones where they don't really mention a proportion relationship. You kind of just have to figure it out for yourselves. It kind of sneaks up on you a little bit, and a lot of people find it really hard to figure out the actual answer. But I really want to get you to understand that when you read these types of questions, just think immediately inverse proportion, okay? So let's actually look at the questions first. For example, we've got here, it takes 3 builders 4 days to build a roof. How long would it take for 6 builders to build the roof? Okay, now our immediate thought here is you go, well, if it's 3 builders and then 6 builders, that's double the amount of builders, so then it's just 8 days, right? I feel like a lot of us fall into that trap. We go, right, so I've times the builders by 2, so I'll just times the days by 2. But think about it logically. If I have more people, if I have more builders working on the same amount of work, the same roof, ideally, hopefully, it should be shorter, shouldn't it? It should take less time. That's why it's inverse proportion. Because in this example, the more builders I have, the fewer days it should take. So both of those variables, the builders and then the days, are going in opposite directions, aren't they? If I have fewer builders, it's going to take more days. So that's where a lot of people kind of go wrong. So, I mean, this one's a little bit nicer because obviously 3 and 6 are, one's multiple of the other. But the way that I would work it out, let's say if they're more complicated, is, okay, well, if I've got 3 builders, it takes 4 days, I would like to work out, first of all, how long does it take one builder? And again, naturally, you're going to go, yeah, I just need to divide like 4 by 3. But no, it's inverse proportion. We need to do the opposite. If I've only got one builder, it's actually going to take 3 times longer, isn't it? So, in order to find, in this particular example, obviously one builder, you have to do 3 times 4. Okay, so it's actually, it would take 12 days for if I had only one builder. Now, how long does it take for 6 builders? This is when I can actually then divide it, right? Because it's going to be more builders, so therefore a shorter amount of time. So 6 builders would be the 12 days divided by 6, which is 2. So we get 2 days. Obviously, I've kind of gone around the houses with this explanation. The numbers here are a little bit easier for you to just think, oh yeah, I could probably just half the 4 because I've doubled the 3. But it's just so that when we go through the next few examples, or if you do get numbers that aren't related, like 3 and 6, you know exactly the method. Okay, so find out how long it takes for one builder. In this particular example, it's a builder, by timesing, and then divide to find the actual number that they want. Now, often this question is asked with a part B, which says something along the lines of, what assumption did you make when you made your estimate? It's pretty much always the same answer, obviously just relate it to the context. We assumed that each builder works at the same rate. Okay, so it's something about the same rate. So just apply it to the context. In this case, the builders worked at the same rate. Because obviously, technically in real life, you can have one builder that's a lot more productive or a lot faster than another builder, so you might end up having more builders, but some of them might not be very good, so then you end up not having it take that many days less. Okay, so just basically write down, whenever it says what assumption did you make, relate it to the context, but say something along the lines of, we assumed that everything was at the same rate. So now let's have a look at another one. It takes 5 taps 30 hours to fill a swimming pool with water. How long would it take for 2 taps to fill the pool? So again, you kind of think, oh, okay, these aren't, necessarily related in terms of, 5 is not a multiple of 2. It's a little bit more complicated than that. But you think, oh, well, it's, the number of taps has got smaller, so the 30 hours should get smaller. But no, right? If you've got fewer taps but the same swimming pool, it's going to take longer, isn't it? It's going to go the opposite direction. So I want to do first to find out how long would it take if I had only 1 tap to fill the pool, and that's when we do our multiplied. Remember we said in the previous one, 5 taps would take 30 hours, so 5 times 30 gives me 150 hours. So if I only had 1 tap, it would take 150 hours. I actually have 2 taps though, so then I can do the 150 divided by 2, which gives me 75 hours. Okay, that's why we have this kind of method, because the previous one was a little bit more simple to figure out, but this one is a little bit harder, I feel like, to work out the numbers because they're not multiples of each other. Again, what assumption did we make? In this particular context, we assumed that the taps, you could say something like the taps fill up the swimming pool at the same rate, or the water comes out of the taps at the same rate. Do you see what I mean? So it's something about the same rate, but to do with the taps or the water. Okay, so we have fewer taps. It's obviously going to take longer than 30 hours. I've seen some questions where they basically give you sometimes 4 graphs drawn, sometimes even 9 graphs, and it says match it up to the correct proportion relationship. And you've got a little table with the proportion relationships, and you have to put the letters, right? Hopefully some of you have come across that before. So we're just going to go through and explain the proportion graphs. Obviously, in our first 2 videos, we used the letters Y and X. They can be any letters, but in this case, it relates literally to a graph, doesn't it? This is the Y-axis, this is the X. So in this case, we were saying it's a formula, it's an equation, but think of it as a graph equation, right? Y equals K, which remember we said is constant, is a number times by X. So it could be anything really, but let's just say it's Y equals 2X. What type of graph is that? If we just look at that and forget about proportion, if we just look at that equation, what type of graph is it? For GCSE, you need to be able to recognize straight line graphs, quadratic graphs, cubic graphs, so x cubed, reciprocal, and exponential graphs. Okay, so there's only like 5 or so that you need to recognize. So obviously going to have to be one of those, isn't it? This one, hopefully you'll recognize it as a linear graph. Okay, it's just x. It's not x to the power of 2. It's not quadratic, it's not a cubic graph. It's not divided by anything. It's just y and x. Linear graphs are straight line graphs, aren't they? Straight line graphs are normally in the format of y equals mx plus c. Now, technically in this case, the plus c is just 0, which is fine. You can have that. It might not have a plus c technically. And the k is therefore the gradient of the line, isn't it? Anyway, so the point is, if it says y is directly proportional to x, and you remember that obviously the formula for that is y equals kx, just think, well, what kind of graph is that actually? It's a straight line graph, isn't it? So just look for the straight line. Obviously, when we've also said directly proportional, that was the fact that they're both, in this case, x and y, going in the same direction, aren't they? So you can see here, as x increases, y also increases, doesn't it? Okay, the next one is a bit harder, and that's why I want you to have seen it rather than be in the exam and trying to guess. Y is inversely proportional to x. Now we know, you should already have this memorized, that the formula for that is y equals k over x. Again, k is just a number, so let's pretend that it was 2 over x. Sometimes we think, oh, well, it's inverse, so it's probably just the opposite of the other one, it's going down. Well, no, because this formula is not a linear formula. This is actually a reciprocal graph. Well, the formula is a reciprocal formula. Basically, reciprocal is y equals any number over x. X is in the denominator. Now, yes, reciprocal graphs are something that you should recognize anyway. You might just not have known that they relate to inverse proportion in this way. Okay, so we're just trying to connect the dots here. Different parts of the syllabus that you might not have thought overlap, they actually do. So that's really it for proportion graphs. It's not really a topic in itself, it's just something to touch on because I have seen questions about this, matching up the graph with not the equation even, but just they say this, sentence, and you have to match it up. Okay, so just be really familiar with the formulas, which you'll need anyway for proportion questions, but just then try and think a little bit further and actually kind of interpret, okay, yeah, y equals kx, don't just look at it as face value, like try and think, well, what other areas of maths have I seen that before, or something similar to that before? It's a straight line, isn't it? This one is reciprocal. So hopefully you'll have seen all the other videos as well. That should be everything you need to know about proportion. If you're really happy and confident with algebra, and obviously graphs are including with algebra, most of this should be fine anyway. It's really just algebra, isn't it, ultimately? But thanks for watching this video. Check out any of the other videos if you want to go back. They'll be linked down below, and make sure to subscribe.